Hi, stat students. This is 1.2 notes. I'm not sure how long this will be, but we'll kind of figure this out as we go. So first we're going to do some dot plots and stem and leaf plots. Both of these super duper easy. So we have some data on how long people travel to get to work every day and we'll make a dot plot and a stem and leaf plot. Okay, so a lot of numbers here. So if we look at our data and look at low numbers, 8 looks like a low number. And I see a 31, and that seems about it. So we need to make our scale accordingly. So on our dot plot, I like putting 0. It doesn't really matter that much. Count by fives. That should be good. All we're doing is putting dots. 24, 18, 25, 21. So there we go. There's our dot plot. We can kind of see that I smushed a few things because of the size of my dots and my scale, but we can see that the center is right around here. And we have a couple on the ends. Our stem and leaf plot, we have stem with 0, 1, 2, and 3. And we'll put it, and it doesn't have to be in order. So we have 24. There's my leaf. 18, 25. So you'll see that I ran out of space for my 20s. What I could have done is called splitting the stems. And what I could have done is I could have had zeros, ones, twos, and that would have been nice because I have so many in these 20s that this would have been 0, 1, 2, 3, 4 under that first two, and then the second two would have been 5, 6, 7, 8, 9. And that would have split it a little nicer. So for example, the 24 would have gone here, the 25 would have gone here, the 21 here, the 27 there. And we would have done the same for all of them. And that would have made it look a little nicer, but you could see that most of these numbers are in the 20s for sure. So what these do is it shows every single data point, which is a very nice thing. And then we can describe this data. So we have 4 different ways to describe this shape. Shape is a very, very important thing. So we have this one in the middle where it's kind of got the same on both sides. This is symmetric. And that one has kind of a bell shape to it. It goes up and back down, but not quite. It's just symmetric. For now, that's what we're going to call symmetric. This one is also symmetric, but we also call it uniform. I would say both words. I would say that this is a symmetric uniform. This one is skewed, and this is skewed right. And this one is skewed left. A nice way to remember that is wherever it trails off is where the skew is. So this one trails off at 6, 7, 8, and that's why it's skewed right. This one trails off that way. This one is also symmetric, but it's another special case. We call this bimodal because there's 2 peaks. So other ways we could talk about these peaks. This is a single peaked symmetric. This is a uniform symmetric. This is a bimodal symmetric. Technically, we could have trimodal or even more, but bimodal and unimodal are kind of the main two. But you don't even have to say those words necessarily. You could talk about the peaks. So we have this little acronym for describing data. We always want to describe the shape. O stands for outliers, but also unusual characteristics. So we have gaps in our data. If there's like a big gap, there's a little bit of a gap here, but nothing out of the ordinary. A cluster is similar to an outlier. This would kind of be like a cluster where we have 3 dots that are kind of farther away. Outliers, there's a formal definition that I'm going to show you. but just again far away from the data, and then peaks. So this is if we have different numbers of peaks, kind of like the bimodal, trimodal, or if we have kind of like a weird little peak somewhere. So we have shape, outliers, and unusual characteristics. C stands for center. So we can do our center with the mean. We could find the center with median. Those are the main two. Technically mode, but not really. That one's kind of going away. So the center here is at 5. Both the mean and the median are going to be around 5. And this S is spread. We could find the spread by finding range. We could do the interquartile range, the IQR, which we're going to talk about a little later. We could also use standard deviation or variance. So all of those talk about how wide the data is. So this one goes from 1 to 9, so this range is 8. It talks about the wideness. Okay, so remember this acronym SOX: shape, outliers, center, and spread, because you're going to use those every time you describe the data. So for this example, we have energy costs, top freezers versus bottom freezers. So annual energy costs in dollars compare for refrigerators with top freezers and refrigerators with bottom freezers. The data below are from the May 2010 issue of Consumer Reports. So what we're going to do is we're going to try to be very specific. This is something that I'm going to use to type up, write on your homework all the time in different things. BS, be specific. So in the bottom freezer, let's talk about the shape. It looks like because there's these points out here, they might be outliers. You can maybe even call them a cluster. You could also call this a gap in our data. Just be careful what you're saying. We'd say that this one is more skewed than this one. Now again, we want to be specific. So if we're comparing these distributions, the shape, the bottom freezer's distribution is more skewed right. Now notice what I said, the bottom freezer's distribution. Again, I'm talking about these distributions. I was very specific saying the bottom freezers. If I just said the bottom, I could have confused those because I put the bottom on the top and the top on the bottom. I did that on purpose to kind of trick you. Make sure that you're being specific. Okay? On the AP test last year, it looks like people knew the material, but when they were writing, they were not as specific as they needed to be. And that's where you lose some points. So the top freezer distribution is more symmetric. Okay? But what I said here is enough. These words, comparing words more or less about the same, are really important. O, outliers and unusual characteristics. Again, I would accept a lot of things here, but I would say that there's potential high outliers in the bottom distribution. So the bottom freezer's distribution has potential, because we don't know for sure, high outliers. Okay, and that's enough for now. C, it doesn't say find the exact center, it says compare. So the center for the bottom freezers, that middle, is higher than the center for the top freezers. So I'm going to say that. Higher, more than, just use those comparing words. And for our spread, the bottom freezer's distribution is much more spread out than the top freezer's distribution. Now I should be saying distribution in here, I'm being lazy. Again, be specific. So again, the bottom freezer's distribution is more spread out. Than the top freezer's distribution. Again, that's pretty specific. You could say that the spread is larger instead of more spread out. It's probably better, but this is fine. They should know what you're talking about. Now we have frequency tables and histograms. Again, both very easy ideas. You've probably seen them before. So frequency table is a table that shows the total for each category or group of data. And then the histogram is similar to a bar graph, but there's ranges. But in a histogram, each bar is for a range of data, and the bars touch. Okay, so I'll show you. So we're going to create a histogram, a frequency table and a histogram for the number of home runs by batters in a local home run derby. Okay, so we need to set our ranges, so we need to look at our data. It looks like my low number is 2, my high number is 17, so let's count by fives. So 0 to 4, 5 to 9, 10 to 14, and 15 to 20. Okay, and then my frequency. So a nice way to do this is just use the tally mark. So I have 7, 17, 14, 2, 7, 9. So we have 3, 5, 4, and 2. So when I draw my histogram, I have my ranges. I have 0, 5, 10, 15, and don't think too hard about this. And then my frequencies. So I have 1, 2, 3, 4, 5. Kind of hard to draw on this, but that's okay. You guys get it. So from 0 to 4, I have 3. From 5 to 10, I have 5. From 10 to 15, I have 4. And from 15 to 20, I have 2. See how the bars touch? Just list the frequencies. Okay, this is still one variable statistics. Notice how we only have one variable, just those number of home runs, but it looks like there's 2 because I have ranges and frequencies, but it's really not. If I were to describe this distribution, my shape, it's kind of hard to tell because there's not that many bars, but it's roughly symmetric. Oh, no, I don't see any sort of outliers or unusual characteristics. C, center. Again, hard to describe, but we could say the center is around 10. We try to avoid this around 10 because there's ranges, but it's really hard to tell. The center is going to be between 5 and 15 somehow, but kind of roughly in the middle there. And then S, our spread. We can say our data starts at 2 and stops at 17. So we could say that the range is 15 if we want, 17 minus 2. Or we could just say what I just said. The data begins at 2 and ends at 17. Okay, all of those are fine. We're just talking about how spread out this data is. All right, so that's it. And hopefully that's pretty easy.